Welcome back. Today, in this session, we will see an example using dynamic array. Dynamic array. We know that a dynamic array is an array which is created during runtime, or the memory required for the array is reserved during program execution, so that, as in the case of static array, there is no chance for insufficiency of memory as well as wastage of memory. So in this example, we will see an example to accept n numbers into an array and to find out the largest of that array. Here we will use the concept of subscripts in an array as well as the concept of pointer arithmetic for accessing array elements. So forget about the hash include, all these things using namespaces and all. We are just looking into the core of the program. So here int main, starting the main section. In this program we want a dynamic array and we want to get the number of elements n, and we need a loop and we want a pointer. So we are going to declare some variables int n comma I, then small. So the program is to find out the smallest element, small, and then we need a pointer, integer pointer, int star ptr. Now we are asking for the number of elements, enter number of items seen n. So this is the number of elements that we are going to input to the array. So far we have not created the array. We are going to create the array using dynamic memory allocation. So we are creating a dynamic array. So we have got the number of elements that we want to store. Now based on this number we are going to create an array. So the declaration is we are going to create an integer array int star ar equal to new int of n. So this is the declaration to create a dynamic array of size n. Here the n is number of items in the list, of number of numbers in the list. So this statement will create an array like this. Suppose n equal to, for the time being, n equal to 5. So the user input n equal to 5. Then, since it is an integer number and we are handling with GNU Linux Genie compiler, so n into 4, there is a total of 5 into 4, that is 20 bytes will be reserved. Suppose this has a starting address, say 1000. We have the pointer. Name of the pointer is AR. That is the name of the dynamic array. And inside this there will be 1000. So this points the starting array. For the time being we have taken n as 5. So there will be 5 different locations like this. This will be 1000. Here it will be 1004. Here it is 1008. Here it is 1012. Here it is 1016. These are the base addresses of each and every locations. So AR points the first item in the array, first location in the array. So this is the creation. In this way we have created an array, dynamic array. Memory is allocated. Now the space is ready for storing the numbers. Now we want to input n numbers into the array. How we can input? So we are writing this C out. Enter numbers 1 by 1. Numbers are to be entered 1 by 1. This is the message. Then we are opening a loop for I is equal to 0, I less than n is the maximum number of items, I plus plus. Cin, name of array is AR, we are using that AR of I. So this loop will execute. Only one statement in this loop, so there is no query basis and all. This loop will execute 5 times. I starting from 0 to 4, that is n minus 1. For the time being n is 5. So I is equal to 0, 1, 2, 3 and 4. So all the elements will be accepted. So in screen you can see enter number 1 by 1. See something like this. This is your screen. On the screen, first you will get enter number of items. Enter number of items. So we will type 5 and enter key will be pressed. Immediately after asking that question, the next question will be enter numbers 1 by 1. Message will be enter numbers 1 by 1. So we will input say 10, 70, 25, 8, 9, etc. So what happens? The first time we will enter 10 and type enter key. That item will be stored into AR of I, that is mean AR of 0. This location is AR of 0. This is AR of 1. This is AR of 2. This is AR of 3. This is AR of 4. So when we type the number 10 and n plus enter key, that data will be passed to AR of 5. So that number 10 will get stored here. Then again this loop executes. Next number will be asked. So we will input 70. So that 70 will be stored in AR of 1. AR of I means second time I will be 1. So AR of 1. And then 25, 8, 9 and finally that loop ends. So in this way all the elements are entered into the array. Now we want to find out the smallest of these array elements. How we will find? So we know the procedure. We will assign this element as the smallest one. then that element will be compared with the remaining elements. And if a largest element occurs, it will be taken as the largest element. Here the question is to find out the smallest element. So we are here assigning small, let small equal to AR of 0. Let the first element be the smallest element. Now we have to compare this small with the remaining elements. So we are writing the loop for I is equal to 1. No need of starting from 0. Already the 0th element, the first element is taken as considered as the small one. So we are starting the comparison from 1 onwards for I equal to 1. I less than n I plus plus. Now opening the curly brace. So here we are using the pointer arithmetic for accessing elements. We are making one more statement here. We have a PTR here. We are writing like this: PTR equal to AR. PTR equal to AR. What happens? A pointer is created, that is PTR. PTR equal to AR. What does it mean? This contains 1000. So this also points this location. PTR equal to 1000 means this PTR also points this location. Now, instead of using AR of 0, AR of 1, etc., we are using this PTR. So here we are going to compare if star PTR plus I less than small. If PTR of I is less than small, we have to make some rearrangement, that is small equal to star PTR plus I. See the comparison here. Star PTR plus I. PTR is 1000, that we know. I is 1. So PTR plus 1. Adding 1 to PTR, what happens is pointer. Adding 1 to pointer adds the size of the memory location, that is, or the data type. So here it is integer, so it is 4. So 1000 plus 4, 1004. Then value at 1004. Value at 1004. Value at 1004 is 70. So here if 70 less than, what is small? Small is AR of 0. AR of 0 is 10. So 70 less than 10? No. So there is no change of, no need of interchanging. So that step is over. Now the loop continues. I becomes 2. I becomes 2. So star PTR plus 2. 2 means, adding 2 means it will add 2 into 4, that is 8. So 1000 plus 8. 1000 plus 8 means this number 25. So here 25 less than 10. No. Again that is also skipped. No need of making rearrangement. Again, value of I becomes 3. Now 3 means 1000 plus 3. I mean PTR plus 3. 1000 plus 3 means 1000 plus 3 into 4, that is 12. So it becomes 1012. So value at 1012 is 8. So here 8 less than small, that is small is 10. You have taken smallest 10. So the answer is yes. Here we make some interchanges. Small equal to star PTR of 5. What does it mean? So we have a memory location called small. Initially it contained 10. So PTR of 3 means this 8 is assigned to small. That is, this 10 will be gone and 8 will come there. And again I becomes 4. So here PTR plus 4. PTR plus 4 means 4 into 4, that is 16. 1000 plus 16. Value at 1016. Value at 1016 is 9. 9 is compared with 8. Whether 9 is less than 8? No. So again there is no need of interchange. Then again this loop continues. I becomes 5. So this I is not less than n. There the loop ends. Now after the end of this loop, at the end of this loop what happens? This location, this small contains the smallest of these items. Now we want to bring this C out. Smallest is small and ending the program. So this is the way of accessing a dynamic array. Dynamic array can be, so as in the case of the other array, we can access with the help of pointers. Here the important thing is that we have created the array and the memory is allocated. How many bytes are reserved? The bytes actually required. Not more, not less. So there is no chance for wastage of memory or insufficiency of memory. So this is an example for using dynamic array in a program.